Hi, grade 11s. Today we'll be proving trigonometric identities. To prove trig identities, we use the basic trig identities. We looked at these in our previous lesson. Now, the basic trig identities are the tan x is same as sin x over cos x, meaning if I see tan x, I can replace it with sin x over cos x. Another one, which is the square identities, is sin squared x plus cos squared x is equals to 1. From this, if I like, I can take the cos squared x and put it to the other side. Then I'll be left with sin squared x. And sin squared x would be 1 minus cos squared x. Or, if I didn't take cos squared x to the other side, I would have taken sin squared x and be left with cos squared x. And therefore, cos squared x would be 1 minus sin squared x. Let's see how we can use this to prove identities. Trig identities are not very difficult. It's just that you need to remember what you've learned before, and your algebra must be good. Now, when you prove an identity that this side is equal to this side, it's usually taking the side here and you simplify it until you get that answer. So I'll be taking the left-hand side. So I'm taking the left-hand side, which is a cos of x divided by 1 minus sin x. The aim is that I get that answer, so I must be looking forward to that thing. So something must be done here. Now, one of the trick will be, if I were to take the cos x over 1 minus sin x, and then just multiply it by 1, it means that I didn't change the left-hand side. So what will be that 1 be? I've got to make a plan. It's something divided by something. Those two things must be the same. Check here. I want to find 1 plus sin x as my answer. Let's check what happens if I say 1 plus a sin x here divided by 1 plus sin x. So this is 1. I didn't change the thing. So when I simplify this, the answer is this multiplied by that one there. So it's cos of x multiplying 1 plus sine of x over 1 minus sine x, which is multiplying 1 plus sine x, which is, if I leave that, because I want that as in my answer as over there, I'll leave that as it is, as cos of x into 1 plus a sine x, which is divided. Now these are the factors of difference of two squares. So this is same as 1 minus sine squared x, because when you fold this out, you get that answer. Now note that what I get here, 1 minus sine squared x, is something that we said we know of. We'll check again on it. Sine x over, what is 1 minus sine squared x? In our basic trig identities, the 1 minus sine squared x is cos squared x. So this is cos squared x. Now, if I continue on this side here, I've got cos of x into 1 plus sine x divided by, what is cos squared x mean? It means that is cos of x times another cos x. You see now that this cos x goes once there and cancels that goes once. So my final answer is 1 times sine x, 1 plus sine x, over 1 times cos x, which is cos x, which is same as what I was proving. So I can say this answer is same as the right hand side. The left hand side equals to right hand side. Let's look at another example. We've got this one. Again, we'll take the left hand side. So the left hand side, which is a cos of x over 1 plus sine x, is plus a tan of x. I want the answer to be this. 2 terms to become 1 term. It means that I've got to simplify these fractions until I've got one thing. But we know what is tan x. Tan x, we said, is sine x over cos x. So this is the same as cos of x over 1 plus sine x. So plus sine of x divided by cos of x. Now these are fractions. I want have to have same denominator, common denominator. So our LCM will be 1 plus sine x, which is down multiplied by cos of x. Now this will cancel this. I'm left with cos x, which multiplied cos x there. So I'll get a cos squared x. Now this cancels that, so I'm left with this, which will multiply by a plus sine x. So it's plus sine x multiplying 1 plus sine x. So this is cos squared x. If I remove brackets, there is plus sine x plus sine squared x all over 1 plus sine x times a cos x. Note that I'm not multiplying this one out because our 1 cos x must be left like that. So we can see something familiar here. If I group this is cos squared x plus sine squared x, then plus sine x all over 1 plus sine x times a cos of x. But we know what is cos squared x plus sine squared x. Cos squared x plus sine squared x is 1. So if I go on the other side there, so I've got 1 plus sine x now over 1 plus sine x, which is multiplied by cos of x. I can put this in brackets. What happens if I put them in bracket? The 1 plus cos sine x cancels once, it cancels once. So on top as a numerator, I've got 1 over, at the bottom is 1 times cos x, which is cos of x. And this is the answer which is given there. So the left hand side now is equal to the right hand side. Let's look at another example. I've got to prove that this is equal to that. Again, let me take the left hand side. The left hand side, which is tan x plus 1 over cos of x. But all of this is squared. This must prove that is that answer. Let's check what we get. But remember what is tan x. We said tan x is the same as sin x over cos x, which means that these things you must know them by head. So this is a sine of x divided by cos of x. So plus 1 over cos of x, but this is squared. But remember that we need to work out the answer inside bracket first. So this has got the common denominator inside the bracket. So the common denominator is cos of x. So now I've got a sine of x plus 1. If I were to remove the brackets here, it means that the top is squared. So I've got a sine of x plus 1 times sine of x plus 1, because it was squared, over the bottom one is also squared, which gives us cos squared x. Now note that I want to get that thing. I need that. I still need that. So I must get rid of this. Now what is cos squared x? So let's write the numerator as it is. It's sine of x plus 1 times sine of x plus 1. So all of, what is cos squared x? Cos squared x, we said is 1 minus sine squared x. So it's 1 minus sine squared x. Now, of course, 1 is minus sine squared x, but I've got 1 minus sine x. But this is a difference of two squares. I can factorize this. So what I've got now is sine x plus 1, is sine x plus 1 over difference of two squares. It's 1 minus sine x and 1 plus sine x. You see how important it is to know your algebra. Now, you can see now that 1 plus sine x is the same as sine x plus 1. So this goes once there, that goes once. So my answer in the numerator is sine x plus 1 times 1, which is a sine x plus 1, divided by 1 minus sine x times 1 is 1 minus sine x. This thing is the same as that thing, even though that sine x plus 1 is same as 1 plus sine x. If you like, you can still write 1 plus sine x over 1 minus sine x, because those are the same thing. Now you can see that this is the same as what they wanted us to prove, which is right hand side. Now, ladies and gentlemen, you've got yours to do, to try on your own from your textbook, the Siavula textbook, grade 11, chapter 6, 6.2 Trigonometric Identities, exercise 6.2. You just do number 2, A up to G. It's very easy. Good luck, ladies and gentlemen.